And we're back. Welcome back to aMATHretic. Today we will be talking about exponential inverse functions and begin to discuss logarithms. Exponential functions are interesting because they have no starting or ending point. The domain of the function ranges from one end of infinity to another, stretching on forever. The range of the function will usually be expressed as x is more than a number or y is less than a number, or vice versa. When you find the inverse of an exponential function, the domain of the original function becomes the range of the second. Likewise, the range of the original function becomes the domain of the inverse function. If we graph the equation f of x equals 2 to the x power, we end up with a line that looks like this. The domain stretches from negative to positive infinity, and the range is y is more than 0, because the line will never actually reach 0. Once we find the inverse of the function by switching the output and the input, the domain and the range will switch, and we will end up with a line that looks like this. We can verify that these lines are in fact inverses, as they are both symmetric about an imaginary asymptote here. Now you may be confused how to find the inverse of an exponential function. The inverse of an exponential function is known as a logarithm. Logarithmic functions switch the input and the output of an exponential function. Logarithms look like this. They work by undoing what the original exponential function does. There are, however, important rules that you must follow about logarithms. The base logarithm can be any positive number except 1, because any power will always equal 1. X must be a positive number, because a negative number of a logarithm will not compute. Logarithms are a simple way to explain the inverse of exponential functions. See you next time. Thanks for watching. And we're back. Welcome back to aMATHretic.